everyone. In this video, let us solve some questions on Thevenin's theorem. So this is the question. So first, carefully observe this question. They have given a box and inside that there is a circuit which is placed here. So we have to find the Thevenin's equivalent circuit for that part which is inside this box. Okay, and after finding the Thevenin's equivalent circuit, we have to find the current through this load resistor. And they have given three different values of the load resistances, that is 2 ohm, 10 ohm and 100 ohm. So for these values of resistance, we have to find the current. Okay, we have to find the current. So first let us find the Thevenin's equivalent circuit. And you know how to find the Thevenin's equivalent circuit, right? So it will be having a voltage source in series with a resistor, that is RTH. VTH is nothing but it is an open circuit voltage. So that is your Thevenin's voltage, open circuit voltage. So now if I consider these two terminals, okay, I will consider these two terminals. So to find out RTH, you know, we will have different cases like which contains only independent sources, only dependent sources, and there will be circuit which contains both dependent and the independent sources. So this is the first case where we have only independent source. So in this case, you know how to find the RTH, right? So in that case, we have to short the voltage source, open the current source. So in this problem, we have only voltage source. So that will be easier one. So you have to short this. So this will be shorted, and here you have 3 ohm and here you have 6 ohm. So this is the terminal, right? This terminal I'll mark it as AB. Okay, this is the AB. So here we are going to find the open circuit voltage also. But now we are finding the RTH. So 3 ohm is in parallel with the 6 ohm resistor. So you know that equivalent will be 2 ohms, right? 2 ohms. You know how to find the equivalent resistance when two resistors are in parallel. So R1 R2 divided by R1 plus R2. So that will give you 2 ohm. Next, to find out the open circuit voltage, what you are going to do, these terminals will be open circuited, and here again we are going to place this voltage source, that is 9 volt source. We have to find the VTH, that is nothing but VOC, open circuit voltage. So here 9 volts, so we can use the voltage divider rule, right? So voltage divider rule will be 9 into where you are going to find the voltage, that is 6 ohms, then 3 plus 6, that is 9. So this is 6 volts. So this one will be your VTH. So now I will draw the Thevenin's equivalent circuit. This is 6 volts and we have RTH as 2 ohm, which will be in series. So this is actually the Thevenin's equivalent circuit for this part, right? Now we have to take the load resistor. We have to take the load resistor RL. So this is variable now. So I will fit in different values of resistance and I will find out the current through it. So first, if I take it as 2 ohm, what will be the current through this? Current through this, that will be 6 divided by 2 plus 2. Okay, that will be 6 divided by, that is 1.5 ampere, right? 1.5 ampere. Next, if I take 10 ohm, what will be your answer? That will be 6 divided by 12. So that will be your 0.5 ampere. That is when it is 10 ohms. For 2 ohms this one, for 10 ohms it is 0.5 amperes. Then we have 100 ohms. So that will be 6 divided by 102. 6 divided by 102. That will be the current that is flowing through it. Okay, so that will be around 0.06 amperes. 0.06 amperes. This is the current. That is when RL is 100 ohm. So when RL is 2 ohm, the current is 1.5 ampere. The current through the RL, that is 10 ohms, is 0.5 ampere. And when it is 100 ohm, it is 0.06 amperes. Okay, so this is how we are going to solve the questions based on Thevenin's theorem. So we will be having the terminals AB, and here we have 6 ohms and here we have 4 ohms, right? So this is the terminal, right? Across this only we have to find the RTH. So 6 into 4 divided by 10. So it is 2.4 ohms. 2.4 ohms. This is the terminals across which we have to find. So this is shorted. So we are left with two resistors, 6 ohm and 4 ohm, which are in parallel. So 2.4 ohm is the RTH. RTH is 2.4 ohm. So now we have to find VTH. Okay, we have to find VTH. So open circuit this terminals AB. Open circuit it. So we have 6 ohms. Then we have A and B. Then we have 4 ohms. Then we have minus plus, that is 8 volts. Then we have 2 ohms. So this is the AB. So now we have to find the voltage across this one. Okay. So we can say that these two are in series. Right? These two are in series. AB so this is the 8 volt, this is the 4 ohms. So now what happens, we can apply the voltage divider rule. We can apply the voltage divider rule. So this one will be in this way only, right? Minus plus. So 8 into 6 divided by 6 plus 4. So it is 4.8 volts, right? So why I am not considering 2 ohm is because it is in parallel with the voltage source. So the voltage across 2 ohm is also 8 volts, and here we can easily apply the voltage divider rule. Okay, that is 6 ohms and 4 ohms. This will be divided here, right? So what I did, I am neglecting this 2 ohm resistor. So this is the voltage. Why I have taken this, because the sign convention of this voltage source in that way. So in that way only that will be divided, right? So this is minus plus. So here we will be having minus plus, that is 4.8 volts, and then we have RTH, that is 2.4 ohms, and this is the terminal AB, and I am keeping the resistor as it is, that is 3 ohm. Okay, so this is the Thevenin's equivalent circuit.